Alright, so let's talk about perpendicular bisectors of triangles. Alright, so what exactly is the perpendicular bisector theorem? That is, if a point is on the perpendicular bisector of a segment, then it is equidistant or the same distance from the endpoints of the segment. And so right here, CD is my perpendicular bisector. And I know that because it creates a right angle right here. So it intersects line AB at a right angle, and it also cuts line AB in half because we can see here that we have these congruence marks. And so our theorem states that then this line will be equidistant from the endpoints of the segment. And so that means that CB would be also congruent to AC. So if CD is perpendicular to AB and AD is equal to BD, then AC is congruent to CB. So these two lines would be congruent. That is our perpendicular bisector theorem. So now we have the converse of the perpendicular bisector theorem. So that states that if a point is equidistant from the endpoints of a segment, so we see here that C is equidistant from the endpoints AB because we have these congruence marks here. So if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if AC is congruent to CB, so these lines are congruent, then CD is perpendicular to AB. So we can conclude that CD would be a perpendicular bisector, therefore AD would be congruent to BD. So that is the converse of the perpendicular bisector theorem. So now let's look at two examples, one using the perpendicular bisector theorem and one using the converse. Alright, so in this problem we're asked to find RS. So we can see here that we already have two congruent lines or segments here at QT and TS, and we already have a perpendicular bisector because RT would be a bisector because it cuts QS in half because these two are congruent, as I just mentioned, and it's perpendicular because we know here we have this right angle. So RT is a perpendicular bisector. So we can use the perpendicular bisector theorem because that states if a point is on the perpendicular bisector, then it is equidistant or the same distance from the endpoints of the segment. So that will tell me that R is on the perpendicular bisector, so it would be equidistant from the endpoints. So my endpoints right here are Q and S. So equidistant meaning the same distance. That will make RQ congruent to RS. Alright. So now in order to find RS, I need to find the value of X. I need to find X. And so, since we've concluded from the perpendicular bisector theorem that RQ is congruent to RS, I could simply take each expression and set it equal because they are congruent. And from that, I could solve the equation to solve for X. So inverse operations, just using those algebra skills. 7x equals 4x plus 27, subtracting 4x. 3x equals 27, dividing by 3, x equals 9. Alright, so I found X, but I'm not done. We're asked to find RS. So the only thing we have to do is plug it in right here for X. Alright, so RS is equal to 4 times 9 plus 5, 36 plus 5. So RS would be 41. So we found RS. Could we have plugged it into RQ? Well, yes, because they are congruent. So we should get the same length. If we plug it in, 7 times 9 minus 22, 63 minus 22 does in fact give me 41. Alright, so we found RS is 41, and we know that also RQ is congruent, and it will also be 41. So now for this example, we're asked to find AB. So we want to find this length right here, AB. But now, of course, we could use the converse of the perpendicular bisector theorem, because AC is congruent to BC. So that would mean that C is equidistant from A and is equidistant from B. So if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So we can use the converse. So since this line, or this point C, is on the perpendicular bisector, that would mean that CD is the perpendicular bisector. So again, bisect means cut something in half equally. So we can conclude that AD is congruent to DB, because DC again is the perpendicular bisector. So it cuts AB in half. So AD is congruent to DB. So to find x, we could simply set these two expressions equal. 5x minus 11 equals 3x plus 17. And once we find x, just like we did in our last problem, plug it back in. So again, just using inverse operations to solve. Subtracting 3x. 2x minus 11 equals 17. Adding 11. 2x equals 17 plus 11 is 28. Dividing by 2. X is 14. We're not done. We've only found x. We want to find AB. So I'm going to plug it in to 5x minus 11. So 5 times 14 minus 11. That gives me 70 minus 11. So AD, 70 minus 11 gives me 59. Alright. So now since we know that AD is congruent to DB, DB should also be 59. So in order to find the whole thing, we just add 59 plus 59. However, I'm going to actually plug it in to DB as well. And I'm doing that to make sure that my x value is correct. Okay, because if your x value is incorrect and you plug it in and then you just double that answer to get your final answer, if your original x value is incorrect, you're going to get an incorrect answer. So we know that our x value is correct if we get the same answer. So I'm plugging it into both. So 3 times 14, 42, plus 17. So that does give me 59. So I would always just double check and plug it into both to make sure your x value is correct. So now each segment here is 59, and so we want to find AB. So we simply add 59 plus 59, or we can multiply 59 times 2. Doesn't matter. It's going to give you the same results. I'm going to just multiply it by 2. So AB equals 2 times 59. And that gives me 118. So AB is equal to 118. And we know that because we've used the converse of the perpendicular bisector theorem to solve for x and then plug our x value back in. Alright, so we've reached the end of our lesson. I hope you understand perpendicular bisectors and its converse. So thank you for learning with me. Some related videos are angle bisector and a mid segment of a triangle. Don't forget to please like, comment, and share. And if you haven't already, subscribe to Peach Pie. Again, thank you for learning with me.